Scientists have discovered that the Earth's crust is divided into plates that have been gently shifting over the planet's surface for millions of years. What could this place be where deep within the Earth, pressures are causing the crustal plates to deform? The ground bends to an extent before breaking and snapping into a new position. Seismic vibrations are generated during the faulting process. Some of the vibrations are so slow that it takes several seconds for one wave to travel to the next, while others are so fast that they can be heard. Scientists can see exactly where fissures break through the Earth's crust owing to the countless small earthquakes that occur in California every year. Yes, it is the state of California. The notorious San Andreas Fault is an example of a continental transform fault. The San Andreas Fault has been the epicenter of several earthquakes, the deadliest of which being the 1906 San Francisco quake, which claimed the lives of over 3,000 people. Since the last earthquake on the San Andreas, seismologists and geologists have been keeping a careful check on the fault line since they consider it to be nothing less than a ticking time bomb. They are aware that an enormous catastrophe might strike at any moment and that California has to be ready. Exactly why do scientists worry about the San Andreas fault line? And what would happen if the catastrophic disaster they're anticipating actually takes place? Well then, let's find out. On April 18, 1906, abrupt displacement along the San Andreas Fault caused the devastating San Francisco earthquake and fire, bringing the fault's existence to global attention in a spectacular way. However, due to periodic displacement along the fault, this earthquake was just one of many that have occurred throughout the fault's lifespan of around 15 to 20 million years. The San Andreas Fault marks the border between two such plates that meet off the coast of California. Earthquakes along the fault line are caused by the northwestward movement of the Pacific Plate on the west compared to the North American Plate on the east. The San Andreas is the most important fault in the complex fault system that underlies the coastal rocks of California. The whole length of the San Andreas Fault system is almost 800 miles, and it goes down at least 10 miles into the Earth. From a few hundred feet to a mile in width, the fault is a complicated zone of crushed and shattered rock. The San Andreas Fault zone is connected to and branched off by a large number of minor faults, small cracks, fault gouge or pulverized rock, and the occasional solid rock chunk may be seen in nearly every road cut across the zone. The San Andreas Fault runs from northern California southward to Cajon Pass in San Bernardino, forming a continuous narrow split in the Earth's crust. Several branching faults, including the San Jacinto and Banning faults, share the movement of the crustal plates southeastward from Cajon Pass. The term San Andreas is commonly attributed to the northeasternmost branch of the fault zone along this stretch of the fault zone. A linear depression exposes the presence of the San Andreas Fault for most of its length. From the air, the lineal arrangement of lakes, bays, and valleys in this trough is noteworthy. However, when viewed from the ground, the characteristics are more modest. Many people passing around Crystal Springs Reservoir near San Francisco, along Tamales Bay or via Cajon or Tejon passes, for example, may be unaware that they are in the San Andreas Fault zone. The fault can be identified on the ground by carefully analyzing the terrain. The fault zone is distinguished by unusual landforms such as long straight escarpments, narrow ridges, and shallow undrained ponds, generated by the settling of small blocks inside the zone. Many stream courses veer dramatically to the right as they reach the fault. The San Andreas Fault causes a horizontal motion between blocks on each side of it. The block on the other side of the fault would appear to have shifted to the right if one stood on one side of the fault and looked across it. This kind of fault movement is known as right lateral strike slip in the scientific community. During the 1906 earthquake in the San Francisco area, roadways, railings, and rows of trees and plants that spanned the fault were offset several yards, while the road at the head of Tamales Bay was displaced about 21 feet, the highest offset record. The terrain west of the fault migrated substantially northward in each case. The sudden offset that causes a large earthquake happens on just one portion of the fault at a time. Total offset builds in an unequal manner over time, usually due to movement on one and then another segment of the fault. The parts that cause major earthquakes stay locked and inactive for hundreds or thousands of years as strain accumulates. Eventually, in tremendous lurches, the strain is released, causing massive earthquakes. Other segments of the fault, on the other hand, appear to tolerate movement more through steady creep than by rapid offsets that cause large earthquakes. In the past, these creeping parts did not cause earthquakes of the magnitude witnessed on the locked sections. Since its formation around 15 to 20 million years ago, the geologists estimate that the San Andreas Fault has been displaced a total of at least 350 miles due to the earthquakes and creep. Geologically identical terrains on either side of the fault, currently separated by 150 miles, were discovered in studies of a section of the fault between Taejon Pass and the Salton Sea. This suggests that certain crustal blocks may have travelled through more than 20 degrees of latitude. The pace reflected by these ancient offsets is consistent with the rate recorded during historical time, which is a challenge to grasp given the magnitude of the movement involved. As much as 2 inches per year of drift has been measured by surveying efforts. There are stretches of the San Andreas Fault and other plate boundaries where major earthquakes have not happened for a very long period. These voids are known to scientists as seismic gaps, and in many cases they have been able to accurately predict when huge earthquakes would occur in these voids. Geological research reveal that significant earthquakes have occurred on the southern San Andreas Fault at around 150-year intervals over the past 1400 to 1500 years. The southern San Andreas hasn't had a major earthquake since 1857, making it a prime target for a quake in the near future. Even though it has been just over a century since the devastating 1906 earthquake, the San Francisco Bay region is still vulnerable to moderate-sized quakes that might cause significant damage. Large earthquakes probably won't happen without warning. Multiple years of increased seismicity, maybe including several foreshocks of roughly magnitude 5 along the fault, may precede such an earthquake. Also, seismologists anticipate surface changes, such as a reduction in the length of survey lines across the fault, changes in elevation, and the impact on strain meters in wells prior to the next major earthquake. The part of the San Andreas Fault at Parkfield in central California, where a moderate-sized earthquake has occurred on average every 20 to 22 years for around the previous 100 years, is a major place for study on techniques of earthquake prediction. Numerous terrifying earthquakes such as the 1857 Fort Taejon quake, the 1906 and the 1957 San Francisco earthquakes, the 1989 Loma Prieta, and the 2004 Parkfield earthquake have shook the area around the San Andreas Fault throughout history. Scientists have been fretting about the big one for a while now. Yuri Fialko, an associate professor at the Scripps Institution of Oceanography's Green Institute of Geophysics and Planetary Physics, conducted research in 2006 showing that the San Andreas Fault has accumulated enough stress to trigger an earthquake of magnitude 7 or higher. The study also discovered that the chance of a major earthquake was rising at a rate that was quicker than experts had predicted. It was announced a few years ago by the head of the Southern California Seismic Center that the San Andreas Fault looks to be in a critical state and might produce a significant earthquake at any time in the coming years. Experts have cautioned the people that the southern section of the fault looks like it's locked, loaded, and ready to go, which is nothing new for Californians, as we've established that the region has weathered its fair number of earthquakes in the past. If that's the case, then why are seismologists sounding the alarm? The tension between the plates has been steadily increasing since 1857, when the disastrous 7.8 magnitude 1906 San Francisco earthquake ruptured the fault, and again in the 6 magnitude 1989 Loma Prieta earthquake. No earthquake of this size has occurred along the southern San Andreas Fault before. Due to this, experts are speculating that a massive earthquake is coming to this area. It's feared that this will be the big one because of the cumulative stress in this area. Aside from the San Andreas, the Hayward Fault, which runs along the base of the Berkeley Hills and right through the University of California, is a ticking time bomb. It runs beneath a theatre and a few dorms on the stairs of the California Memorial Stadium. Scientists already know that the Hayward creeps ahead gradually, but they also know that faults rupture and shatter, and that this rupturing will occur abruptly and without warning. According to Richard Allen, a Berkeley professor, Hayward is an extremely vulnerable fault line that hasn't triggered an earthquake since 1868, and is thus due for a large earthquake in the near future. Allen predicts that a Hayward earthquake will completely liquefy the stadium field. Acclaimed specialists have stated unequivocally that huge earthquakes are an unavoidable reality that Californians cannot prevent. But what residents can do is prepare for such a disaster. California is constructing 3 important lines of protection against potentially dangerous earthquakes. Buildings in earthquake zones should be designed and constructed to withstand rattling movement. Lucy Jones spent the whole year of 2014 working with the then office mayors in Los Angeles to uncover risks and prepare the city for the inevitable. Building regulations for older structures can be amended to demand retrofitting to withstand earthquakes. Some cities have plans in place to fortify or demolish structures that are prone to collapsing. The other line of defense is strategic land use, which lessens the negative consequences of disasters. Power, communication, and internet networks should be reinforced, and backup systems should be in place to guarantee that communication is not completely cut off in the event of an earthquake. But it's not as simple as it seems. Such ideas take billions of dollars in funding and years to accomplish. Experts are unsure when the big one will occur and whether it will be as large as they predict. But given that California has had its fair share of earthquakes in the past, it's only natural that residents take every precaution to limit the harm they might wreak. When do you think the San Andreas Fault line, which California sits atop, will finally give way, causing a devastating earthquake in the state? Tell us in the comments.